Okay, today's problem is find to find the uh, lexicographically smallest string after removing all the star asterisk character, no, star character. So first, let's go through the description, and I already highlighted the most important keyword. Yeah, so we are given a string f, and it may contain any number of star characters. Your task is to remove all star characters in the following way. We will delete the leftmost star and the smallest non-star character to its left. And if there are several smallest characters, we are allowed to delete any of them, and we're required to return the smallest resulting string after removing all the star character. So actually, I think this problem is not difficult. It's easier than yesterday's problem. It's just it's based on only one trick, and once you realize it becomes pretty straightforward. Yeah, so and we need to pay close attention to the phrase the smallest non-star character to its left. Like we always remove the smallest non-star character. So actually this problem could be solved by greedy approach, and by realizing this idea, the following idea, like so we don't want to delete smallest non-character which are at smaller indices. Why? There are two reasons. Because the smaller the index is, the more impactful is it. Yeah, like think about it. Like we are talking about lexicographically small, so it means that the small index will be much more impactful than the bigger index, right? And second reason is I actually made a mistake, right? So mistake, yeah. So the delete character will always, there are two cases here, and whether it will always be replaced by a character that is bigger or equal to it, and in that case it will certainly not make it smaller, right? And the in the second case, the delete character could be replaced by a smaller character, but this only happens when the delete character is the one immediately before the star character. Why is that? Let's take an example here. For example, if in this case, we could see that the smallest character that to the left of this star is certainly B, right? So if we delete B at 1, at 0, 2, or 2 index, it will be replaced by a bigger character, and it will make the character as the next string big. So we wouldn't want that. And we also and so we will choose B here, right? So if we choose the B at the 4 index, it could be replaced by A, right? Which is smaller than B, and even when it's not A, we will still choose or be at the 4 index. Why? Because this B is less impactful than B at 0 or 2 position. So we will choose B at the 4, index 4. So to make it clearer, we'll write down the 4 string that so 4 resulting string after remove the A, after remove B at 0, 2, and 4 index respectively. If we remove B here, the array will become CB, DB, etc. If we remove B at 2 index, will become B, C, D, B, and if we remove the fourth the B at 4 index, it will become B, C, B, D, and you can see that the first two string is certainly bigger than the last one, because C is bigger than B. So yeah, so the first one is already bigger than the third, and we now consider the second and the third one. So it have the same two leading character, and D is certainly bigger than B, right? So the third one is the smallest. So from all that, we now could conclude that from all the smallest character available up until the current left mode, star will remove the right mode one to obtain the lexicographically smallest tree. So the trick to ON have now come up with the main logic to implement the algorithm. Basically, it's just a greedy one. Like we look through the character, and when we encounter a star character, we'll always remove the current smallest character at the right mode position, right? So the second important thing is how to implement the algorithm effectively. And so we have to find a way to effectively track the current smallest character and its right mode occurrence. How we do this? Let's think about it for 1 minute. And what is the data structure to effectively solve such require to satisfy such requirements? Yeah. If your answer is minHeap, then yeah, you have the same idea as me. Yeah, it's minHeap. Like we always maintain the character. As we look through all the character and its index, right? But we would like to use the biggest index, right? The right mode one, so we will like take the negative of it. Yeah, that's it. Let's code it up. Okay, so let's go through the code. Also, we'll remove indices to track the index all the indices. In add that will remove character. Got it. right? And the most important data structure to solve this one effectively is minHeap, right? And we will look through each character of string X, and if the character is not star, we will calculate the corresponding integer just for a better processing. So no big deal here, you don't have to do this, and we will push the number and the corresponding negative index into the heap. And if we encounter a star character, we will top the current lab mode as the current smallest character, and it is right mode occurring, and we record the index into remove indices. After going through the whole string, we will construct the resulting string. We will again go through the string add again, and only append the characters that is not star and not in the remove indices. Yeah, so and then with the return the string, and it's pretty simple and it's work. We submit it. Yeah, so it get accepted. Yeah, good luck. We will see. Hope that will.
In the next episode of Human Solving Leetcode.
That's the end of my explanation for Leetcode daily challenge today. I hope we'll see you in next video. Bye bye.